Good morning. My name is William Young, and I'll be covering the software operations and risk management briefing for Group 2, Team Australia. During the cyber operations and security brief, we'll be covering these discussion points in the next few slides. Australia's overview, software assurance, software development lifecycle, known supply chain risks, software options, implementation timelines, and recommended software and software costs. The cyber operation and risk management brief that we'll cover today will cover Australia's related operations to their cyber operations and risk management. Some of the discussions we already mentioned will be cyber assurance, cyber development lifecycle, cyber and supply chain risks, existing software, software options, recommendations, explementations, and the costs involved in those implementations and the cyber or software development lifecycle. In conjunction with that, Australia's production and data insurance will be discussed in the software assurance section. However, the availability within the software they choose is essential, as well as the integrity of the data that they protect. Security needs to be able to respond in a quick manner, ensuring that they approach those mitigations that is part of the incident response plan. Australia needs to be able to set expectations within the software development lifecycle to ensure that the systems they procure go through a good verification and validation process, and we'll discuss that in the next slide. Software insurance is essential. Over the last few decades, there has been an increase in cyber incidences. Some statistics showing that there has been 2,266 instances on an average of 164 cyber attacks per day between 2019 and 2020. In the software assurance, this includes the development and applications of tactics, techniques, and procedures for guaranteeing that the software operates as intended while reducing the risk and vulnerabilities to malicious attacks or faults that could damage the organization in any way or Australia. The Australian government provides a high insurance evaluation program involving the rigorous analysis and testing to identify risks and vulnerabilities in such software. Organizations can utilize the consumer guide that Australia provides to evaluate these products and to ensure that they're on the list, which are confirmed by the ACSC, which has gone a rigorous cryptographic and high assurance evaluation process. Australia has attended the Global Economic Summit, and the expectations related to the 5i network infrastructures are to avoid installing unapproved software that may have malicious code part of the source code. Additionally, if software is approved, then it may be utilized at the summit, and vulnerabilities later identified at the summit should be attended to immediately and patches provided. Also, if any stakeholders at this summit are placed at risk due to software exposures, a cybersecurity specialist should mitigate those risks before continuing any operations or discussions. Software assurance is an essential part of the software development lifecycle that will be discussed in the next section. We discussed the needs and expectations for quality software in the previous section on software assurance. Australia uses many methodologies to train and conduct certifications, such as Project Management Body of Knowledge, or PMBOK, or PRICE2, and SDLC, or Software Development Lifecycle. However, we'll focus essentially on the critical attributes of the current SDLC. The SDLC is a methodology that defines a method for developing superior software. The SDLC's methodologies are broken down into essential points or 7 phases. Some of these phases require requirement analysis, planning, software design, such as agricultural design, software development, testing, deployment, operation, and maintenance. In addition, Australia uses Agile. An example of a SDLC. Agile is described as a project delivery methodology that focuses on software development frameworks. Agile relies solely on close work with the consumer during the complete development of software rather than working off a sign-off of comprehensive conditions. Examples of an Agile method is including extreme programming, lean, and scrum. Other examples of SDLC that we are not really going into is waterfall, interim, V-shape, Big Bang, and spiral. However, organizations must develop a well-defined delivery when implementing any type of SDLC model. Organizations can achieve a peak performance level of management control and documentation if the SDLC is done accurately. As a result, software development can complete a high-quality software program at a low cost in a short amount of time. Again, we'll cover recommendations on cost in a later slide. However, currently the low price ends because the SDLC is well tested and provides a well-structured flow of phases. That's why we choose Agile over some of the other ones we mentioned. Further cost reduction is anticipated by anticipating those mistakes, such as asking end users for feedback, redundant rework, and after the fact fixes. So make sure you do everything correctly the first time. I discussed what type of methodologies included in the SDLC and the different modules like Agile that Australia can use. Though Agile is recommended for the use in Australia's SDLC, it's up to the business and organizations to determine which one fits their requirements. The following sections will discuss the supply chain risks and challenges for Australia and available options and recommendations. Supply chain risks. So with Australia's supply chain risks originates from known suppliers, manufacturers, distributors, or retailers involved in government, business, or any other small business software development such as products and services. Also, the supply chain risk can transfer from organizations to consumers depending on the risks and vulnerabilities associated with those software. An efficient and effective cyber supply chain risk management will protect those systems during the lifetime of that product or services. An inherent risk, though, in the supply chain is every time an Australian government talks with the supplier, distributors, retailers, or manufacturers. These areas of concern can cause consequences or national considerations, foreign control, and foreign influence and interference. National considerations is the distributor, the supplier, and retailer and manufacturer that should be considered by the organization and their involvement in their system, services, and products. It is recommended that organizations research these suppliers, retailers in depth and validate the report through a third-party supply to ensure that any type of exfiltration, malware, or tampering in the past either has been eliminated, or if there are any, then consider a new supplier. Foreign control is when distributors, suppliers, retailers, and manufacturers are subject to foreign government laws. With Australia, they have a control on the price for what software may be purchased. However, there are ways around that through VPN and other protocols that can mask their IP addresses, but most consumers in Australia are subject to high fines and other items if this happens or caught. Political lobbying is a great example, and lobbying practices are done openly and in straightforward style. And that is with the foreign influence and interference, which the society in such a way that aids the government in interests, like we mentioned, lobbying, which is not much of a concern. However, when executed covertly, such methods can be deceptive, corrupted, or hostile in nature if used that way. Therefore, any attempts to influence sovereignty or interests of the nation is classified as a foreign interference and can become a real risk in the supply chain. The three mentioned risks that we discussed above can impact other security practices, such as best practices techniques, or the transparency in the efficiency like pen testing, unwarranted access and privileges, characterization of distributors, suppliers, and retailers. An option to mitigate some of these risks discussed in this section is to categorize those distributors, suppliers, and retailers and treat each one correctly upon the sensitivity of the data that they protect, access, or request privileges, such as with the Australian government or any other Five Eyes nation government, where most information is considered secret or top secret, and that should be taken into effect when dealing with these suppliers. Additionally, suppliers should only require access to the system to assure appropriate patches and monitor requirements and block access to other critical areas. Furthermore, no matter what distributors, supplier, retailers, and manufacturers are considered, high-risk organizations should establish a defendant cybersecurity expectation in a memorandum of understanding or MOU to ensure they correctly manage their security postures in the cybersecurity chain. Lastly, building trust among these distributors or suppliers can strengthen their partnerships and develop common cybersecurity goals, such as sharing best practices and threat intelligence, such as the Five Eyes Nations Agreement, assuring any type of intelligence or cyber intelligence. So the following section we discussed the known supply chain risks, and now we will move into the implementation timelines. We just covered the supply chain risks and some of the areas that are associated with that, such as national considerations, foreign control, and foreign influences. Now we'll discuss the implementation timelines associated with software. But before we talk about the time it takes to implement software, we must understand what happens in the development process and that timeline. As we discussed in SDLC, there are different methodologies that go with choosing SDLC versus the other two we discussed. Some of these methodologies can start to plan by building a process for that software. Within the mentioned above SDLC phases, some of the main phases we need to look at is the requirement and design, planning, architecture and development, and software testing. Where we start seeing most of the time it takes is within those three areas. We can think of the whole process as building a house. Requirements design take 2 to 4 weeks, or as described in building a house for making blueprints. Planning, architecture, and development takes 3 to 6 months, and we can describe that as scheduling your contractors to lay the foundation and construct the house. The final step is software testing, which approximately takes 3 to 6 weeks and is described as when the homeowner is doing their walkthrough and inspecting the home, make sure there are no defects or vulnerabilities within that house or software. On average, 4 to 9 months is the required time to design, develop, and test software. However, many changes depend on the complexity of the product the organization or business is searching for, and many factors will increase that time frame. Also, the KPMG Information Technology has stated that 85% of software development go over the time frame we just discussed. The implementation phases within the SDLC falls between the development and the testing cycle as mentioned. The vendor or retailer will use software engineers to integrate the software which will exist with existing systems, and the time frame can extend beyond a few months or more complex projects. In addition, all the phases discussed in this section and SDLC are essential in the Agile approach, though some phases happen simultaneously. In addition, many influencers change the overall time frame initially requested to build custom software, which again pushes the recommendation towards COTS or versus GOTS, which we'll cover in the next slide, which is commercial off-the-shelf or government off-the-shelf products. However, the functionality and integration will be the driving factor in the development with large and small scale products. We just finished discussing the timelines for implementing software development lifecycle We just discussed software options such as commercial off-the-shelf, modifiable off-the-shelf, government off-the-shelf, and NATO off-the-shelf options. Now we'll go into recommended software, languages, and software costs. We haven't really discussed heavily about coding language in the previous slides and in software development. However, it is an essential aspect of the software and helps the performance and overall speed and scalability of that product. Script language may be easier to develop than Java scripting. However, the enterprise solution requires a robust development coding language to exceed beyond long-term objectives. Based on the average and range cost of associated software development lifecycle, the price tag can lay between $50,000 and $250,000. However, you can definitely see that going up. Of course, a more straight application will tend to cost less. However, rebuilding software from scratch and dependent on whether the software will be used in a previous or integrated system or executing a complete overhaul could increase that even higher than $250,000. But organizations tend to spend a significant amount of time of their overhaul on legacy systems and do not approach the time and required budget needed for reintegration or upgrades to a system or suites. Now we'll go into the final conclusion of the cyber operations and risk management brief. We just went over the cyber and operation management brief covered by Australia Group 2. Related to their cyber operations and risk management, we went through the software assurance, the software development lifecycle, supply chain risks, existing software and software options, recommendations, and explanation of costs involved when implementing and procuring software through COTS, MOTS, GOTS, or NOTS. Australia's approach to software development and its cyber operations is designed to construct tactics, techniques, and procedures to manage a multifaceted cybersecurity threat and reduce and mitigate harm through a method with clear contingency plans. Before Australia's business, governments, and organizations or agencies can accomplish these plans, they must decide on that methodology or the Agile model and the SDLC methodology. At this time, the Agile model is the most common choice for many businesses. However, others can guide specific software requirements. In addition, industries and governments can lean towards COTS products because of their cost effectiveness and flexibility in the long term versus developing their own, which then they would have to outsource to correct those vulnerabilities later on. Also, GOTS, MOTS, and NOTS are available as an option, but we discussed some of the pros and cons with some of those. The types of SDL methodologies to the production of the product all define the timeline of the implementation and cost of the entire process. Therefore, a logical approach needs to happen in every aspect of the software development lifecycle. This type of approach will achieve the goals set by the business or government. Also, this type of approach will ensure specific requirements are met in the product to fulfill desired effects. Thank you.